gotta do. Hey, 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 I'm making a move. Study long.
So this is something that I've personally never done before. Is create an interview type atmosphere, but I think we're kind of interviewing each other, or at least almost having a forum to explain what we do in the robotics, industrial automation, or automation world at large, how we try to affect it, but also how people affect us. And it's funny how you and I met. We were just talking about this, how I posted a video about this woman using a robotic arm. She had a stub, and she was using this robotic arm to grab things like an apple, things as delicate as grapes. She was even using a knife to cut, brush her hair, and things like that. And you had made a comment on the post. You interacted with it. And of course, you had mentioned to me that a week earlier, you had saw a similar, or actually that particular company's article in a magazine. And so I thought that was really nice and want to touch base with you, learn more about what you do. And it turns out you guys do something very similar to what I posted. And I love the world and myself more and more as you tell me, I understand better. I want people to know kind of who you are, what you do, what you guys do best, but really why you do it and how you've impacted people so far.
Yeah. So my name is Ryan Saavedra, and I am the CEO and founder of Alt-Bionics, and we're a San Antonio-based medical device company that creates and develops affordable AI-enhanced bionic prosthetic devices for below-elbow amputees. That's a mouthful, but we're going to be starting with below-elbow amputees, and then we're going to be moving on kind of later in the company's life cycle to other areas of limb differences. So like upper or above elbow, probably shoulder, and then go into lower extremities, ankles, knees, hip disarticulations, and elsewhere. But for now, we're starting with bionic hands because we believe we can affect those prices the most. And that kind of brings us to how I got started on this whole thing. So about 3 years ago, I was independently researching what engineers actually did. I had no idea. I was still in my sophomore year of college, and I didn't know what electrical engineers did. And so I started researching the different fields of engineering, and I came across robotics. And then that had a subcategory of its application in prosthetics. And then I came across a man by the name of Johnny Matheny, and he was part of a project at Johns Hopkins. I forget if it's university or medical, but DARPA had funded them about $120 million to make the most advanced bionic arm in the world, basically, like for their veterans or for anyone who's missing a limb. And they successfully did that. And these devices, I mean, they're incredible. To begin with, they're incredible, amazing devices. But once I got deeper into it, I found out that they cost, upwards of $200,000, or some could cost that much. And it never really made sense to me because, sophomore year of electrical engineering, a little bit. And I knew enough because I'd worked with some constituent components of these devices before to say like, well, that doesn't really add up. And so I spent the last 2 or 3 years basically researching and seeing if I could researching how these devices were developed and seeing if I could make it for less. And so, sorry, that's a lot. So in my final year at university, I found an amazing team, and with them, we developed an AI-enhanced bionic prosthetic device for about $600. And that's about 98% less than the most expensive alternative on the market. And we successfully tested it on an amputee by the name of Ryan Davis. He's an Army Ranger. He was involved in an IED explosion, and he was missing his arm above the elbow. And so we brought it over to him, and we told him, you can do anything you want with this hand. What do you want to be able to do? And all he wanted to do was bring in the nurses and give them all the bird. And so I'm not one to deny an Army Ranger his jokes, and so I happily obliged. So it was kind of then and there. His family was all there, and they were all smiles, and the nurses were all laughing. They're like, "That's incredible! What's next for this?" And I teased it before. I mean, we won a technology symposium. Everyone was saying like, "This is really cool," but seeing the impact that it made on Ryan and his families and these nurses' lives, it was awesome. And like the actual word, like awesome, not just like, oh, awesome, but like it was really inspiring or incredible. And so then and there, I decided I wanted to try and turn it into a company to see if I could, kind of extend or share that smile with others who could benefit from this device. And so 6 months later, I finished my electrical engineering degree, hit the ground running as fast as I could, and 10 months later, so here we are now, Alt-Bionics is officially funded, and we are doing our best to make these devices as affordable as possible for these below elbow amputees.
That's amazing. Yeah, it's funny. A lot of the work I do, and for people who don't know, I belong to a Miller Resource Group, and we are specified in, or dedicated, I should say, to industrial automation as a whole. Myself, I do robotics, controls, and things of that nature. So what I do is made around people, right? Integrated around people and devices, but not always directly impacted with a human being, like a limb and things like that. So when I saw that video, and then when I talked to Ryan about what he was doing, I think it's even more impactful. Like you really are changing people's lives. And for you guys, if you're thinking about your next steps, right? I know you mentioned the hand is right now. That's what you think you can impact the most. But can you explain to people a little bit how that works? I'm sure a lot of people are wondering, okay, you make it at this price point and make it sound simple, but in layman's terms, for a lot of us who aren't engineers, how does that work?
Yeah, so we use something called electromyography. A lot of these devices are called myoelectric devices or myoelectric prosthetic devices. And basically what that means is that they use electromyography sensors, and those go on the surface of an amputee's residual limb. And we're able to take these very, very low voltage signals that your brain sends to your muscle every time you flex it or contract the muscles. And we turn those into, or we amplify those into something that a microcontroller or a computer can recognize. And then we turn those signals into something into the mechanical motion of the hand. And so it sounds fairly complicated, but it's a pretty direct process. You have a latent voltage every time you move a muscle. We pick that up, we amplify it, and then we turn that into the mechanical motion of the hand. And so I guess that's probably the most complicated part of it. The other part is just, figuring out what the user wants to do, because this can be personalized to whatever level or whatever extent that these users would want. So if they would want to make, like, as you saw in the video with the Esper hand, if you wanted to cut something, that would be a specific grip pattern. You're not really thinking it. Later down the road, sure, maybe a year after using this, you might be able to just think and do it. But you need to actually train your muscles to say, like, okay, this is what I want to do, right? And so the AI or whatever program is inside your hand will recognize that you're trying to grip a knife versus you're trying to throw a ball or you're trying to catch a ball or all these different things. And so there is some type of pattern recognition that goes inside these things. But yeah, that's kind of the general breakdown of how they work.
That's amazing. Thinking about the differences and how people are going to train their muscles, how to grab things differently. It's almost like learning how to walk again, right? Yeah,
it is. It is really strange because to get this device to work, to prove out the concept, I was basically the test dummy for it. So I had about 3 surface electrodes on me, or surface EMGs on me, and I had to retrain my hand to do specific motions. And so they weren't normal motions. Like one of the motions was I had to bring my index and middle and ring finger down to my palm lightly, softly, hard, and then pull back on my wrist. And those would translate into like a soft grip, a pinch grip, and then like a release pattern. And so I wasn't using my hand, but I was using the Bionic hand, and
I had to retrain it. Yeah, you don't think about the way you move and how it could translate, and all the muscles that are involved in it, and back here and things like that. It's second nature to us now. That's amazing. Do you now production-wise, right? Do you have waiting list? How is that working for you when it comes to people who can use them, and how you're manufacturing them, and the rate that you're getting them out?
Yeah, so we have so all of our devices are going to be 3D printed. So that's kind of one of the benefits and how we keep the cost down. So we're using a process called multi-jet fusion, which is a type of 3D printing that I think it's powdered resin that's blasted. I don't actually know the process of it. We work with a company called Additive America. They help us make these things. But it's a carbon fiber nylon 12 composite. And so they're very strong, very robust materials. And we estimate that we can make about, I think 18 per month in year 1, and then we can ramp up production in years 2 on once we're revenue generating. And so after that, it would just be dependent on how many we would need to make the supply and demand of the device. But yeah, we can make about 20 a month, and the assembly, which is kind of one of the more novel things about our device, is really simple. So we have a modular design to where people can or specifically amputees, would be able to, with a remaining hand, should they have it, be able to take these devices apart and put them back together really simply.
Wow.
Like they would come with replacement fingers already in like the packaging. And if you broke a finger on accident, which is a pretty common thing in these devices, you could just take it out of the box that it came in,
plug and
unscrew
play
it, put it. Yeah, exactly. And that's kind of the cool thing. And it still maintains this robust and really functional quality about it.
That's fantastic. Yeah, that's a 20-month it's no small feat, especially people who've probably been waiting, with insurance costs and things like that, probably been waiting for something like this for a long time. And, one thing I like to ask, both when I'm talking to clients, right, and I'm talking to candidates, one famous phrase we like to ask them is, in 12 months from now, if you feel accomplished, or if the person that you hired, you feel accomplished hiring them, does something in particular, right, makes them feel fulfilled, or really, brings out this whole big part of your department. What do you think that is for you at the, from now to 12 months, or the beginning of your production to 12 months? What would that be for you?
So what would be like a milestone or like a large achievement?
Either or. Mm-hmm.
So in a year's time, where we would like to be is our device to market. Kind of that's still our promise, that once we're fully funded, that we'll produce or get this device to market in about a year's time. And I keep looking over here to my right because we have these like rows of these prototype hands just sitting on my desk. I can't show them for patent purposes, but
no worries.
Yeah, we're really far along. We're about, I would say, 38% done, and we just started that year process. But yeah, so in a year's time, we hope to have this device out to market and then be moving on immediately to partial hand prosthetics, because that is the next market that is, I don't want to say corrupt, but it's just, the price points for these devices are very, very high. So with partial hands completely bereft of all these advanced technologies, right? It's just pure titanium. It's a pure mechanical structure. Those cost $10,000 to $15,000. So there's no myoelectric stuff. There's no controls. There's no electronics in it. It's just a mechanical system, and it's $10,000 to $15,000. So we've had a lot of people come to us and say like, hey, I lost my fingers, or my dad lost his fingers, or my grandma lost her fingers, and what can you do? How can you help us? And I keep saying like, that is our next goal. I promise we want to get there as fast as we can, because it's just, these things are quality of life devices, and they shouldn't be as much as they are.
I mean, just like everything we've seen, right, when it comes to pharmaceuticals and medical device, there's definitely an upsell, and unfortunately, it's in the hundreds of percents, right, instead of a small markup. I think one thing that I really appreciated was with that post, the amount of views that I got and the interactions. I really didn't expect it. In my line of work, I post a lot of videos. I post a lot of pictures. I post a lot of added value type comments. Because I'm always learning too. And, I like to be a subject matter expert in the automation world, again, specifically robotics and controls. But, this one in particular, again, was just special for some reason. I guess other people felt the same. But a couple of the comments on there were, I got buddies that lost limbs. This is great. And then I think even the head of Esper made a comment and said that they can apply here. And how would they have known? I'm not sure if anything's going to come of that, but it's just these little connections, like you said. Now you're running into different things where you're working on one, part of the one limb, the part of the human body. People are saying, "Hey, this happened to me," or "This happened to a family member," and it just goes to show that you could start working on one thing, or I could do one thing and then do something different because of the need that comes out of it, the demand that comes out of it, or the engagement that comes out of it. And I don't think we would have had this, 20 some years ago, before we had these types of forums to do that on, and things become more in focus. And I think what you guys are doing is fantastic. And it's definitely a value add, is what we like to call it, right? But it's going to help a lot of people, in both ways, physically and probably mentally too. You have somebody like the Ranger you talked about. That's a big mental, block for some people, not to have the functionality they used to have. And to now have the physicality of something they used to be able to do, is definitely going to be able to affect them in a personal way as well. Maybe get back to an old way of doing things, whatever that may be for them. But for you guys, obviously the bigger, the more you sell, right? And the more production you make, the bigger you're gonna have to grow. It's as simple as that. I mean, do you guys have a timeline of, okay, are we going to do a brick and mortar eventually? Are we going to grow our teams? Your role is going to change. What do you feel is like the next couple of years in the company?
Yeah, so we have a roadmap that basically starts out with us getting this device to market, selling to prosthetic and orthotic clinics pretty exclusively. We want to be able to sell directly to consumers. That would reduce the cost by a unknown amount. We honestly don't know the effect that would have once we are able to sell directly to consumers, but we're still, navigating through some FDA hurdles for direct to consumer. But we begin with prosthetic and orthotic clinics, and we have reference channels of basically the amputee societies, amputee foundations, hospitals, and VA hospitals who basically say like, yeah, I've heard about this hand, etc. And then those are all stepping stones towards the end goal of direct to consumer, and finally a brick and mortar shop where people can come in, be fitted for, and get a prosthetic device, hopefully in the same day. And so they would be able to walk out in a single day. We'd have a prosthetist, we'd have certified prosthetists on our team, we'd have a whole team just kind of in-house, and it would be a simple process. So we've mapped that all out, and that's definitely something that we want to see in our future.
Now, that's a huge difference, right, from what people are trying to fill out applications. They're waiting to be able to walk into a center or a brick and mortar and be fitted for something. It's like going into an Apple shop, right, and wanting a specific iPad and going at that and just having it walking out with it. It's pretty amazing.
Yeah.
Is anybody else doing this right now at all, or have you heard anything like that for any other companies?
Yeah, so I know of two who are doing direct to consumer right now with the same mission as us, and that is Unlimited Tomorrow and Open Bionics. Open Bionics was basically the first of its kind, and this is actually their open source design. So the prototype that you see was an open source design out of this company.
Interesting.
And this was under a license like CC by 4A. So we modified it for our tech symposium. We only modified the mechanical components. The electricals were discontinued. They don't sell this anymore. But so we developed the controls, the AI, the EMGs all on our own. But Open Bionics is going direct to customer. And also I'm pretty sure they have a brick and mortar where people come in and are fitted for prosthetic, and they say about 2 to 3 weeks to get it. And it's sitting at a price point of about 10,000.
Okay.
But yeah, so we still think that we can improve on that a lot.
Absolutely.
And then the other one, Unlimited Tomorrow, they're novel in that they send you out, I forget if they send you, I'm pretty sure they send you a 3D scanner, and you scan your residual limb, you send it back, and then they form a 3D composite socket for you. And then they send you your arm or your hand. And so they're all kind of brick and mortar, but you send over the 3D scan and they send back an arm. And that sits at about 8,000. And so still trying to justify those costs. Every day I'm looking for a different, a different
because I'm thinking of what you told me. I'm like, wow, I mean, your price point is just unreal compared to what I'm hearing about the other people right now.
Yeah, I honestly don't know why, because we've, even if we go direct to manufacturer, get like 2 box electrodes, which are $650 a piece, a battery unit, which is $900, and an EQD set, which is another $1,000. We're barely at 3,000, and that means what's the markup for them? 300%, 500%. So it's crazy. So yeah, we're still looking at margins to keep our company afloat, but not like profiteering at the highest ends. And so yeah, every day still looking to see why it's that high and how we can make it for less. But we're pretty sure we found a way. So
that's incredible. Well, I'll tell you, I'm excited to see how you guys grow. Really, I mean, again, you and I found each other through what I called synchronicity, but you had another name for it. What did you call it when we first met?
Oh, I said it was a lot like the Bader-Meinhof phenomenon, because once you learn about something, you'll start to see it cropping up everywhere.
It's like a car on the road, right? You learn about a specific vehicle, and for some reason you see that car as it comes along, But I truly believe, like, again, with what we're doing in the industry, with all the things we touch and all the things that become intertwined with it, it's such a small street when you look at it, and then it combines to the world and the world's needs and things like that, which is what you're getting into as well. And again, how we like to affect things at Miller Resource Group, we do our best to listen to what a company or hiring manager really needs, because they could be in robotics as well, and they could be doing the same type of thing. They could be thinking of a new medical device, right, to save somebody. We don't know what it is until we talk to people and understand the efforts that they're trying to make and how we can affect it, of course, by bringing in the right individuals. So, while I'm doing it more as a third party, right, trying to bring people together that don't know the other sides exist, obviously you're doing that from a very intimate point of view as well by manufacturing something and using your knowledge and, again, different pieces that people aren't really familiar with, and you're bringing it to the world at a very affordable cost compared to what other people are. And I think that's a tremendous thing you guys are doing. Before we wrap up, is there anything else that you would like to say about the company, about yourself, that people should know?
The biggest thing, I'll always push this, is that, we have a team. I'm not doing this alone. I am standing on the shoulders of my team in college, my team now, and if you go to our website, you can see our full team. We're about 4 mechanical engineers right now, and then a CFO, a CTO, and myself. So we're a fairly small company, but definitely not just me. And you can find out a lot more about our company at Alt-Bionics.com.
Very, very humble. I appreciate that. So everybody go check out that, and check out MillerResource.com, of course, as well, for information on the industrial automation recruiters. We'd be happy to help. But thank you all for joining. Hope you found some value in this, and see a little bit of the future in this video as well. Thank you.
I'm making a move. Study long, study wrong. Ain't nothing gonna happen on its own. I'm making a move. Don't need no angels for this song. I got joy all through my soul. I'm making a move. Get up, get out. Mr. Sun is shining on me.